Hey guys, welcome to Data Wrangling in R. So, if you've done some of the prior learning paths, we've done kind of the intro basics, you may have done the R Markdown section. But before we get into actually doing a lot of this bioinformatics stuff, there is a bit of finagling that we may have to do to some of the data sets. Not everything comes in these nice, easy to load data sets. Sometimes you have to add variables, compute variables, delete things, move things around. You have to make the raw data into an input format that makes it compatible with whatever script or package that you're using. So we're going to do an entire kind of series on how we wrangle data that we get into R. And so stick around. Hopefully you'll learn something. It's not too tedious. It sounds scarier than it is. And let's get into it. Okay. So to start off, we're going to open a new R script. New file, new R script. And let's always remember to annotate our code. So we're going to call this Data Wrangling with R. And so the first thing we're going to do is there's some packages that are built for specifically for wrangling data, so to speak. And so we're going to open the library tidyverse. And so I'm going to run this code real quick. How did I? Tidyverse. So it says I don't have it. So it's possible that it's not installed on here. So what I'm going to do is do install packages. Try running it first to see if you already have it installed, because there's no point in installing it if you already have it. So let's install packages tidyverse. Now why is that not running? Let's try to see. Alternatively, what we can do is we can go to install packages here and type in tidyverse. There we go. All right, install. There we go. So this may take a second, depending on how fast your computer is. It's quite a big package. It's quite a big collection of tools. No install dependencies. Make sure everything's there. Perfect. All right, now let's run this. Okay. So it just kind of gives you an idea of, what packages are attached, things like that. So, all right. The other thing we're going to do is we're going to run another install real quick. Install packages, and we're going to do NYC flights 13. Okay, so let's do it up in the CRAN repository. NYC flights 13. And so this is just a package of data on airplane flights in New York City. The reason we're using this is it's a nice data set. It's a Tribble data set, and we'll get into what Tribbles are a little bit later. But it's already available to you to easily download and install. It has categorical data and stuff that we can group real easy. There wasn't a really good available data set in terms of biological data that kind of matched what we're doing, where all the things we're apply to one data set. So for this series, we're going to use logistics, I guess it would be, data set. So, but if we look at what this data set is, I should say, we're going to have to do the double question mark flights. As you can see here, it's part of the DB plier package. And so it is, well, this is not giving us a ton of information. let's load it real quick. So my data is going to be NYC flights, and we're going to take the flights part. So this has got an array of different things. So if I go back to this, you can see there's airlines, airports, flights, planes, weather, etc. So there's a bunch of data. This is actually a database file, an SQL file. We're just going to take the flights part of it. So let's run that. And so now if we run head of my data, we see that we have the year, the month, the day, the departure time, the scheduled departure time, the departure delay, the arrival time, the scheduled arrival time, the arrival delay, the carrier, the flight, etc. So a lot of data, as you can see. Also here it says whether they're integers and whether they're characters. So we got a whole bunch of different things going on here. So let's annotate and say first we will just look at the data on the 1st of January. So for this, we're going to use the filter function, so we can kind of filter out all the things that we don't need in the data set if we just want to look at a small data set. Actually, let's change this. 1st of January, because you can already see the 1st of January. So let's do my birthday, October 14th. Okay, I won't say the year. So let's do filter, my data, and then let's do month, double equal sign. So the double equal sign means equal. If you do this, it's not going to work. 10, and then the day is going to equal the 14th. So we can run this. And as you can see, it will print everything, but it doesn't save anything. So this gives you just a look at it, right? So now, if we want to subset this into a new variable, we do the following. So we will say October 14 flights, and then you can just copy and paste this code, right? So copy, paste. And if we run this, then we don't get it to print out, but it's saved up in the top right here, right? So we can click on it and we can scroll through all the October 14 flights. Now, what if you want to do both print and save the variable? What you can do then is put it in parentheses. So let's take this, copy, paste it in the next line, and put parentheses on either side of it, and then run that code. You see we have, well, I should have erased this, but here I'll put we'll call this October 14 flights 2, just so we see it makes another variable. So we run it, you get it up here. This is version 2 of it, and we also got the printout. So handy little trick if you want to see what's being printed out while you're actually doing and saving in the variable. Okay, so if you want to filter based on different operators, you can use the following. So we use the equal sign here, right? So one of the big troubleshooting things, the quirks of R, is using the double equal sign as to mean equals. So I'm gonna put this down here as a warning because I want to keep this code kind of away. If we don't use the to mean equals, we get this. So if let's make it just a regular equal sign, like you would logically do if you didn't know the quirks of R, right? So if we run it, it says error and filter, and it even tells you that it knows you screwed up. It says it means you've used a single instead of a double. So make sure that you use the double equal sign. And I'm going to hash this out, so if I want to run the whole code, it doesn't stop there because it thinks I'm made a mistake. So some of the other operators besides equals, so we'll put them all here. So equals is that. We'll say not equal to is exclamation point equal sign. So exclamation point always means not, or the opposite of. So this is the opposite of equals. We can use greater than. We can do less than. We can do greater than or equal to. So that would be that. And we can do less than or equal to. Like that. So those are just some additional operators you could use. So you could say, okay, filter my flights where the month is less than 10. So it'll be everything before. Let's actually run that. Why not, right? So I'm just going to paste this down here, and I'm going to say, call it flights through September. And I'm going to say month is less than 10. Or I could do less than or equal to 9, right? And I'm going to get rid of day, right? Because I don't want just the 14th of every month. I want all the months through September. So if I run that, you see that my flights through September, it's less than my total data, because my total data says I have 336,000 flights. So I have 252 flights. If I were to click on it, you see that I have the months starting with January, month 1, and going through month 9. So perfect. So you use these operators to filter your data in different ways. Like I said, you could do not equal to, I could do not equal to October, so everything but October, etc. So yeah, so that's one way of kind of filtering your data, making it a little bit more manageable, right? If you don't need an entire data set of 336,000, if you're just interested in what happened in October or December or whatever, you can subset it and then just not use your big data. Because sometimes if you're using very, very big data, it can get bogged down your calculations if your computational power isn't scaled to it, right? So you can also use, let's write this out. You can also use logical operators to be more selective. So this would be and, which is the and sign. This would also be or, which is the pipe, which is above your enter. It looks like one solid line on here, but on my keyboard at least it's two. It's dashed lines. And this can also be not. Like I said before, the exclamation point means not, or the opposite of what you're asking for. Let's do an example here. So let's use the function, let's use the or function to pick flights in March and April. So what we're going to do is March, April flights, and we're going to do filter my data, which is our big data frame of everything, right? We're going to do the months are equal to 3, which would be March, and then we're going to put or the months are equal to 4. And so we say run. Problem while computing. Let's see, what did I do wrong here? Flip my months. I think it's month, right? Yep, there's no S. So this is saying it's saying that it can't find, so it says comparison when it is possible for only atomic and list types. So it's saying that it can't find, essentially it's saying it can't find the right column to run that on. So if I run it, okay, there we go. So March and April. So we look and we say all these are March flights. If we keep scrolling, there's like 57,000, so I'm gonna scroll over here, and then we have April flights, right? And that's it. So that's perfect. Now, what if we were to say, let's do this again real quick. What if we were to change this to and, right? If you can, give you a second to guess what will happen. We get 0. Why is that? It's because a flight can't occur in both March and April, right? It's got to be March or April, kind of like time traveled and gone back and flown again at the exact same time in a different month. So, and doesn't work there. But if you're, let's change this to day equals 4. So we're saying find all the flights that happened in the month of March and on the 4th of the month. All right, so if we run that, so we'll say March 4th flights. So we run that, and so we get 977. See, they are all on March 4 over here. Perfect. And the last thing, let's do, what's the best way to do this? Let's do non-Jan flights, just so we can see it real easy. So we'll do filter, my data. We'll say the month is not equal to 1, so it's not equal to January, the first month. So it's everything else, right? So if you run that non-Jan flights, you see that we start, we got the month starting at 10. It's interesting that the order is backwards like that. Or no, it's just kind of in random order. We'll actually figure out how to arrange that coming up. But yeah, so if you were to look through here, spend the time to look through here, there's going to be no January flights in there because we said not equal to 1. Okay, so we'll cut it at that. 17 minutes already. Oh man, where does time go? We'll continue on doing more wrangling of data. This is just the beginning. We'll actually get more into the weeds of how to add columns and things like that in the upcoming videos. And so I will catch you in the next one.